Back in early 2022, we took a look at what was then one of the most intriguing new ideas in long-duration energy storage, the iron-air battery developed by a US company called Form Energy. It was a simple concept, almost elegantly crude in a way, based on nothing more exotic than iron, water and air. The idea promised days of energy storage at a fraction of the cost of lithium-ion, using materials so abundant they made lithium look like rocking horse doo-doo. Then in early 2023, we took another look to see what progress had been made. And it was promising, but pretty limited. Now, those two videos got a lot of attention, but they also prompted plenty of you to leave comments like, "Sounds great, Dave, but will it actually happen?" We're almost 3 years down the line now from that last video, so I thought it might be time to have a look at what's been built, what hasn't, what's working, and what's still to come in what I reckon is a fascinating little niche of the clean tech landscape that has the potential to become a very big player indeed. Hello, and welcome to Just Have a Think. So let's start with the problem that iron-air energy storage is trying to solve then. And to be blunt, it's intermittency. Unless you've been living in a cave for the last few years, you can't fail to have noticed that wind and solar power have been climbing relentlessly upwards along an exponential adoption curve. According to the energy think tank Ember, in 2024, while hydro, nuclear and other clean energies remain flat or falling, growth in wind and solar pushed all clean energies upwards to more than 40% of total global electricity generation. Despite the misguided ramblings of the US president during his recent speech at the World Economic Forum,
China makes almost all of the windmills, and yet I haven't been able to find any wind farms in China. Did you ever think of that?
China actually has more wind capacity than the next 18 countries combined. And since 2020, it's been adding more solar power each year than the rest of the world combined as well, reaching its overall 2030 renewables capacity target 6 years early in 2024. I could keep going with record-breaking stats from other regions like India, Pakistan and Europe. And even in the United States, renewable capacity is on the up and up, supplying just over 20% of electricity in the first half of 2025. Now, I'm not going to patronise you by explaining what the limitations of wind and solar technologies are. You know what the limitations are. So although in the future, when the world has massively overbuilt wind and solar to largely cope with the lulls in energetic weather that our German friends call the Dunkelflaute, in the near term, we are going to need to plug the gaps if we want to keep the lights on 24/7. You've no doubt seen these types of charts before, with a logarithmic scale going up the y-axis representing the most economically optimum discharge times for various energy storage technologies. I won't show you every option here because it'd get too busy, but you've got things like flywheels down here that can discharge relatively small amounts of residual energy for short periods to help with a bit of grid frequency regulation. Then at the other end of the scale, you've got so-called power to gas, which typically uses excess electricity to combine hydrogen with carbon dioxide to make methane. Lithium-ion batteries, fantastic as they are, don't generally get used to cover multi-day lulls. The economics don't stack up particularly well after about 6 to 8 hours of discharge. Pumped hydro works beautifully where there are mountains and water, but there are plenty of places that are not blessed with those topological features, aren't there? So long-duration energy storage, anything from 50 to 150 hours, is no longer a nice-to-have. It's becoming a structural requirement for our increasingly renewables-dominated grids. And that's exactly the niche iron-air aims to occupy. Quick recap of how it works? Why not? Here's a snippet from my previous video. The two main ingredients are basically nothing more sophisticated than good old iron and fresh air. Both are extremely abundant, both are easily accessible, and importantly, both are cheap. The principle of Form's technology is something they refer to as reversible rusting. One of their batteries contains between 10 and 20 stacks of cells, each of which has an anode consisting of pebble-sized pellets of metallic iron on one side and an air-breathing cathode on the other side, all immersed in a water-based, non-flammable electrolyte. As oxygen from the air floods into the battery cell, it reacts with the iron via the liquid electrolyte. That reaction reduces the air to hydroxide and oxidizes the iron firstly into iron hydroxide, which releases electrons, and then into iron oxide, which releases more electrons, all of which can then be harvested to provide electrical energy. As the battery discharges, that rust slowly builds up at the cathode. A full discharge cycle can take up to 100 hours, or roughly 4 days, and unlike lithium-ion batteries, these things can operate quite happily in a very wide temperature range without expensive cooling systems. To recharge the battery, an electrical current can be passed through the cells, which reverses the reaction, liberating the oxygen from the rust and turning it back into iron. That process also takes about 100 hours, so again, not suited to devices that pander to the human obsession with instant gratification, but still perfectly serviceable in a well-planned utility-scale environment. So it's slow and heavy and completely unsuitable for mobile applications, but for fixed grid storage, it has enormous potential. The chemistry naturally supports 100-hour discharge durations, and the materials cost is astonishingly low. So what's the latest state of play with Form Energy then? Well, like so many post-Inflation Reduction Act clean tech projects in the US, Form ran into supply chain bottlenecks, higher than expected construction costs, labour shortages, long lead times for heavy industrial equipment, and more stringent permitting than expected. All external pressures that delayed their original timeline. But Form Energy's factory is now operational in Weirton, right in the heart of the American Rust Belt, on the site of a former steel mill. And according to the company's CEO, Matteo Jaramillo, speaking in November 2025 on the YouTube channel of the investment firm SOSV, Form Energy is now fully up and running with manufacturing and has just shipped to its first major customer, Great River Energy, a generation transition cooperative in Minnesota, serving roughly 1 million members through 22 different cooperative outlets. One of the many advantages of Form's configuration is that their modular unit can be shipped dry, in other words, without the electrolyte. And because it's a water-based electrolyte that can be easily mixed by large, well-established third-party suppliers, that liquid can simply be ordered in once the units are in place and basically poured straight into each battery. That's a smart feature that vastly reduces shipping and handling costs. Jaramillo explained that the company now has a backlog of orders with signed contracts filling up production capacity right through to 2028, including partners like Xcel, Georgia Power and Dominion. Expansion has already begun at the Weirton site, bringing Form Energy one step closer to their goal of having an annual production capacity of 500 megawatts, which, don't forget, equates to 50 gigawatt hours of energy discharge. The plan is to grow their vertically integrated supply and production chain from 300 to 750 employees by 2028. In fact, if you're in the States and you fancy a career in this kind of thing, then check out their website because they're apparently hiring in West Virginia, Massachusetts, and California. And iron air technology appears to be gaining a bit of traction elsewhere in the world as well. In July 2025, a Netherlands-based company called Ore Energy launched Europe's first grid-connected iron air demonstrator in the city of Delft. It's a pretty small-scale affair, but it's a significant step. Operating conditions in high-humidity maritime climates are a great stress test for the chemistry. The company is also planning to ramp up production to 50 gigawatt hours with a 2030 timeline for that goal. Over in India, where this sort of technology would surely be a real game changer in the energy transition, a startup called Meine Electric raised new funding in 2024 to push iron air from lab to early deployment. They're positioning themselves as Asia's first iron air manufacturer, targeting 12 to 24-hour duration applications. And there are apparently iron air research and development clusters in Japan, Israel and Germany. None of those has reached commercial operations yet, but they do give us a glimpse of a rising global interest in metal air options as the energy transition ramps up at pace and stationary energy storage continues to strengthen its market position. So can we all get giddy and excited yet? Well, maybe. 3 things have shifted since I first took a look at Form Energy back in 2022. Firstly, grid limitations and storage requirements are now crystal clear. Multi-day storage isn't optional in a deeply renewable grid. All the major grid operators around the world are now actively modelling multi-day storage as a core requirement. Secondly, Form Energy's moved from concept through to construction and real-world deployment. That's a big deal. Unlike many other optimistic tech startups in recent years, Form has successfully crossed the dreaded valley of death that kills off roughly 90% of energy tech newcomers. Thirdly, the economics look increasingly compelling. If Form can hit the generally accepted target price of around $20 per kilowatt hour at system level, then iron air represents one of the cheapest forms of long-duration storage ever devised. Combine that with the incentives from the Inflation Reduction Act, or at least what's left of them anyway, and iron air battery storage could just possibly become a cornerstone of a US grid transition that is happening, whether Mr. Trump likes it or not. Let me know what you think in the comment section below, but that's it for this week. Thanks as always to the fantastic folks over at patreon.com/justeverthink who enable me to keep ads and sponsorship messages out of all my videos. And I must just give a quick extra special thank you to some folks who joined recently with pledges of $10 or more a month. They are John Spock, Steve Bell, Daniel Lichau, Jerry Beauregard, Ian Painter and Erin Shimpson. And of course a massive thank you to everyone else who's joined recently too. Don't forget to like and subscribe to help us get to our next target of 700,000 subscribers. And most important of all, thanks for watching this far. Very much appreciated. Have a great week and remember to just have a think. See you next week.